Okay, in the previous segment we talked about what a vector is. And so just as a review, we said that distance could be a vector, and then we also said that velocity was a vector, and then acceleration was a vector, and then forces were a vector. And then also we said that different kinds of fields, like the magnetic field, the electric field, the gravitational field, were all examples of vectors. So the next thing is, how do we represent a vector? And a vector can be represented with an arrow. So the length of the arrow tells you the magnitude. So that, let's say that you've got a 5 Newton force and you have another force that is 10 newtons. So how would you represent them? So let's say that the 5 Newton force is an arrow that looks like this. It has a certain length, and then that corresponds to 5. So if you've got a 10 Newton force, and let's say it's going off in this direction, we need to make it so that it's 2 times the length of that one. So the longer the arrow, the greater the magnitude. And then the direction that the arrow points in is the direction that the vector is going in. So we can represent any of these quantities up here with arrows. Okay, now we want to add vectors together. And in case number 1, let's assume that the two vectors are parallel to each other. So in this case here, we've got an object and it's being subjected to 2 forces. So it's being subjected to a 3 Newton force that goes in that direction, and then it's also being subjected to a 10 Newton force that's going in this direction. Now I need to draw this one so that it's about 3 times the length of this one over here. So that's my artist rendition of that. So that's going to be 10 newtons in that direction. So how are we going to add those 2 forces together? So we're going to use algebra, and we're also going to remember that anything that goes in that direction is negative. Anything going this direction is going to be positive. So what we're going to do is take a negative 3, because it's going that way, and then add it to positive 10, and so then that turns out to be 7, and then always remember to put your units on there. So it's going to be 7 newtons. So that then is going to be the force that results when you add those 2 forces together. It's just plain old algebra, and you just have to remember your sign convention. Same thing would be true if you had a box and you were lifting it up, so that the box would be pulling down and you would be lifting up with a force going up. And so again, you could add those 2 forces together. Remembering down is negative and then up is positive. But it gets a little bit more tricky when you're going to be adding 2 forces together and they're at angles. So this one right here, where you've got a 5 and it's going off in that direction, and then you got a 10 and it's going in this direction. So when you add those together, you have to do something a little bit different. So we're going to go to the internet, and we're going to go to PhET and look for vector addition. So PhET, P-H-E-T, vector addition. Okay, found it? Okay, now we've already done this one. So explore in 1 dimension. So that would be this one here. So we don't really need to do that one. So let's go to this one. Explore in 2 dimensions. Okay, now we can grab an arrow here and put it on the table. And then we're going to grab a second arrow and put it on the table. Now if you grab it in the middle, that means that you can move it anywhere that you want, and notice it doesn't change the length and it doesn't change the angle. But if you grab it at the tip, you can change the length and you can change the angle. Alright, so keep that in mind. Whenever you go to move these arrows, always grab them in the middle. Okay, and that won't change the angle or the length of it. So let's simulate this one right here. We need to have an arrow that points in that direction and needs to be, let's say, that long. And then I need to have my second arrow, and it needs to be longer. So I'm going to put it right next to it there, and then I'm going to put it out a little bit further so that this arrow is about 2 times the length of that arrow. Okay, and then you can verify that by looking at these numbers up here. So that's going to be telling you the angle and then the length of each of those arrows. Alright, and then I'm going to grab it and I'm going to pull it down so that it's, is that close enough? Close enough. Alright, so what I want you to do is we're going to click on Sum. So up here, there's a box that says Sum, and that's going to add the 2 arrows together for me. Now, can you see a relationship between those 3 arrows? Alright, so remember, always grab it in the middle, and then take these arrows, move them around, so that hopefully, if you get the right combination, you can generate this arrow right here. Alright, are you frustrated? Well, it turns out it's really easy. So what we're going to do is take this arrow, and you notice it has a tail. We're going to put the tail of this arrow at the head of this arrow. So this is the head of this one. So I'm going to pick this one up, I'm going to put it up here so that it looks like that. And then notice that this arrow fits neatly inside, like that. So notice that here is where I begin. Think of a conga line. So this is where I begin, and then I go over to here, and then I go over to here, so this is where I end. So I'm going to draw a line from where I begin to where I end, and then that turns out to be the sum of those 2 arrows. Okay, so let's try it one more time here. So let me click off the sum, and then let's break them apart. Okay, let's say that this one was going straight down like that. Okay, what would be the sum of those 2 arrows? So this is where you might have a piece of paper to do this. So what's the rule? Okay, here's where it begins. Okay, and then it goes to here. So let's take the tail of this one and put it at the head of that other one. And then my final answer is going to be where I begin, and then I go this way and this way. Here's where I end. So I got to go from here over to here. So I hit my sum button. And now I can pick this one up and I can put it over here, and it works. And then if you click it, let's see, you can click it here. Now, well, notice if I click on this one and I change the angle, do you see how this one changes automatically? Okay, so that's how you add arrows geometrically. There is another way of adding those arrows together by using trigonometry. We're not going to do it, okay? So this is algebra-based physics. But if you take more advanced physics, you would learn about trigonometry, the sine, the cosine, the tangent, and measuring angles. And so actually that's what this stuff up here is more for. So if you had a protractor, you could measure these angles, you could measure these distances, and then use sines and cosines, add them together in order to figure out what this arrow here has to be. We're not going to do it, but that's another way of adding arrows together, is geometrically. All right, so let's put this away. Okay, let's go back to the notes. So if the two vectors are at angles to each other, they can be added together geometrically with a ruler and a protractor. And so we pick up the arrows and we put the head of one arrow at the tail of the other arrow, and then we draw a line from where we begin to where we end. And so that's what's represented here. So we're going to add these two arrows together and we end up with this blue arrow. Okay, so here's an example. This is what's going to be on the exam. Can you add two, count them, two arrows together? So that's all you're going to do. So you're not going to add 3, 4, 5 arrows, just 2. So here are 2 arrows. So these are 2 forces that are acting on this box, and we want to know what's the total force. Now, let's just reproduce this over here. So we got the box, and then we got a force that's going off like this, and then we got a force that's going off like this. So under no circumstances do you do that. Okay, that's not right, because what you've just done is you had this arrow and you put it like this. So you just put them tail to tail. That's not going to work. You have to put them head to tail. Now remember, you can always move them. So you can move them anywhere that you want on your piece of paper, as long as you don't change the direction and you don't change the length of the arrow. So this is where the ruler and the protractor come into play. So notice I put the head of one of those arrows at the tail of the other arrow, and then it makes a big conga line, and then you go from where you start to where you end, and then that's the red arrow. Okay, so can you do that? Now, what about if there had been another arrow? Okay, so we just got through saying that the correct way to have done this was to draw this arrow and then add to it this arrow. But what if there had been a third arrow? So what if there had been another arrow that went like this? Well, okay, so we're going to take this arrow and put it over here so that it goes up like that, and then your final one is going to be that one. Okay, so you can do this with multiple arrows. It's not that difficult. It's just that we're going to stick with just adding 2 arrows together. All right, let's take a break. When we come back, we will talk about static equilibrium.